Good morning, this is your Stat Sensei, Mr. Spensei, and this is an exit ticket on reading computer printouts for regression. So the first thing you always have to do is find where to start because you have a whole bunch of information. Find the word constant, mark that entire row, and know that anything on that row is your y-intercept. This is my y-intercept row, and I'm just going to write y-intercept just to remind myself that it's the y-intercept. The row directly below it is always involved with slope and slope only. So we refer to it as a slope row. Now those two rows can occur anywhere, but they're always one on top of each other. So if you find the word constant, you found both of them. So the very first thing it asks for is the explanatory variable, which EX tells me this is my X variable, which is my height. All right. And in this case, it's in inches. And that is A. The next thing it asks for is the y-intercept. And not surprisingly, y-intercept means it's on the y-intercept row. And it happens to be our very first number. So B is negative 202.035. Not surprisingly, slope is on the slope row, and it happens to be directly below our y-intercept. So our slope is 5.0256. All right. We base the regression equation, which is not directly on here, but we have all the information for it. We base it on algebra 1, which is y equals mx plus b, where b is our y-intercept and m is our slope. But in statistics, we do it as y hat equals b plus mx. We write it in that order. Now the calculator has different letters than that, but that's the order we write it in, b plus mx, where b is our y-intercept and m is our slope. So same thing, just change the order a bit, and there's actually really good reasons for it. So our regression equation is going to be y hat equals, and I'm going to shorten this up to negative 202.03 plus 5.02x. I barely fit that in there. I probably should have shortened it up a little bit more. Sorry about that. The next thing it asks for is the standard deviation of the residuals. Now we have to be careful because sometimes they refer to this as standard deviation, but they're going to say standard deviation of the y-intercept or standard deviation of the slope. That's not what they asked for. They didn't ask for standard deviation of slope. If it's standard deviation of slope, it would have been here. They asked for standard deviation of the residuals. All right, so we'll take a little bit of time right here and talk about that. First off, standard deviation of the residuals is noted by S. So if you find the capital S, you're good to go. Well, the capital S is right here. But this is a time for me to talk to you about some other information on this form on the printout. So other information, if I take the residuals, the 23.95, 47, and divide it by 22. So let's do that real quickly. 2395.47 divided by 22, I get 108.88. So this divided by this equals that. Now, let's take the square root of this and see what happens. So I do that by raising it to the half power. And if I do that, I get 10.4348. Hey, that's my S. That's my square root of that value is S. So technically, I could just give you this number and have you take the square root of it, and you'd be good to go. All right, T statistic for the slope. Well, I notice these two both have the word slope in them, so I must be looking at the slope row. So the T statistics, yes, I have two of them, but obviously I want the one on slope row. So in this case, our letter F is going to be 11.2945. And then I want the p-value for the slope. And the p-value for the slope, we got two p-values. And the one I want is on the slope row, and that happens to be 0.0000. So a really small p-value. All right, correlation coefficient. It's not directly up there. You can look around, it's not there. But there's two things that can make it up. One is you need the sine of the slope. The other thing is you're going to need the square root of r squared. So let's deal with sine of the slope. Use the word slope, must be off the slope row. Matter of fact, I go to the slope and I go, oh, there's no negative sign, so it must be positive. So I have a positive correlation coefficient, and that came from right here, this being a positive slope. The next thing I need is r squared. Well, when I look for r squared, I happen to find two of them, but we'll never use the r squared adjusted, so this one is gone. All right, this is gone. We won't use this one. We'll only use this one, but I have to change it up. I have to divide it by 100 because all percents needed to be turned into a decimal. We need to turn it into a decimal. And to do that, you'll always divide by 100 every single time. So 85.29 divided by 100 is 0.8529. And we're going to take the square root of 0.8529. So I'm going to do that by raising it to the half power. And I get 0.9235. So my correlation coefficient is 0.9235. Please don't forget, there's two parts to finding correlation coefficient. The first is the sine of the slope. The second is taking the square root of r squared after you've converted it to a decimal. All right, I hope this helps and look forward to seeing you on the next one. Thank you.